Okay, so what we're going to do now is we're going to advance this one more level and do something called a phrase cipher. There's a bunch of different names for this, but essentially what we're going to do is we're going to be using a phrase to create our code. So you can see that this has a lot of the components in it from the Caesar cipher, except the shift is not always going to be identical. So the way this is going to work is imagine that we have, I'll move up to the top just to illustrate this a little bit. So if we have a phrase that is like, hello world. And then what we want to do is we want to encode this with the phrase. I'm gonna just pick a word, potato, and we'll just go with potato. That's fine. So what we're going to do now is we are going to find out which letter in the alphabet potato is, or which letter P is, and then we're going to shift the H that many forward. The E is going to be shifted by whatever position O is in. The L is going to be shifted by T. L is only going to be shifted by 1 because A is the first letter of the alphabet. The O is going to be shifted by T. We'll end up skipping this space, and now the W is going to be shifted by how late in the alphabet P is. So we're going to keep spinning through this one to find out how to spin the letters of this word, which is going to make this incredibly hard to decode. But we're going to use the computer to kind of do this work for us. So we've got our accumulator. We're still going to have a shift here. We're going to have a code letter, but now we also need 2 extra things. We need our phrase that we're going to be using for encoding, and then we're going to be using a temporary one that we're going to use to just make an adjustment to our phrase, because some of the things like spaces and punctuation in our phrase are really going to mess things up. So the first thing that we're going to do is we're going to prompt the user for our original text. So system.out.print, enter the text you would like encoded. And then what we're going to do here is we're going to get original gets the value of input.next line. And then our second one is enter the phrase you will use for encoding. And this one is going to be our phrase. Now, before we begin, we're going to have to process the phrase to remove spaces and punctuation. So we only want the letters, and thankfully we have a mechanism already for this. So we'll put a traversal for loop here. So int I equals 0 while I is less than phrase.length I plus plus. Okay. So what we're going to do here now is if, so I'm going to reuse this a little bit here. So if the alphabet.index of phrase.substring is this, meaning it's a letter. So if we find a letter, what we're going to do is temp plus equals phrase.substring I comma I plus 1. And just to do a quick test of this, here's what I'm going to do. I'm going to turn the rest of this program into a comment. And then in here, at every step, I'm going to print the temp. Okay, so if I run this, enter the text you would like encoded. This one doesn't matter. Hello. Now the phrase that we're going to use for encoding, I'm going to put in a bunch of weird punctuation here. So U $T comma U again pound sign and a P. So if I hit enter, what it's going to do is the first time it goes through, it adds on the U. And then the second time, it skips the $, because that's not a letter. It's not in the alphabet string. Then it adds the T, skips the comma. So by using this, we can process ourselves a string that only has the letters. So now we're ready to work on the second part. Okay, so the second part is going to work pretty similarly. If it's not a letter in the alphabet, it's just going to drop it into the coded message. Otherwise, we're going to do something. So what we have to do is first figure out what letter it is we're looking at. So we're going to do that by checking the alphabet for where it is. So we're going to check the alphabet with index of, and for the individual letter we're currently processing. It just occurs to me that I missed a step here, so I'll fix that in just a second. There we go. Why do I have an equals? So there, that's better. Now, the only thing that I forgot to do up here is I forgot to put the, I forgot to change the phrase into the temp. After you process it, you're going to have to throw it back into the original phrase. Okay, so we've found what letter we want to process. Now we have to figure out what is our shift. So that is going to be based on how far down the alphabet the current letter of the phrase is that we're going to be looking at. So here's how this is going to work. Our shift is going to become alphabet.index of phrase.substring. Now, the problem that we're going to end up here is the phrase is going to be a different length than the original text. So this is where we're going to make use of our modular arithmetic, our modular function here. So what we're going to do is it's going to be I modulus phrase length, phrase dot length, sorry. So we're going to go from I modulus phrase dot length to I modulus phrase dot length plus 1. So that went off the side edge of the screen, not plus exclamation mark, plus 1. Okay, so this is going to guarantee that whatever number we're getting out of this, it's never going to go past the end of the phrase. It's just going to keep rotating around to the beginning as long as we need it. Now, what's our code letter? The code letter is going to become equal to letter plus the shift. Now, again, the code letter could go over 25. So this is where we're going to go code letter modulus 26 to make sure that it does not do that. And then we're going to add on our letter. So coded plus equals alphabet dot substring from the code letter to the code letter plus 1. There we go. So I'll run the program, and I'll remove this so that we can see what is happening. And of course, this is a good time to fix some errors. Oh, I'm missing parentheses here, so that's on line 40. Yep, there we go. I think I had another one, but I'll wait until it tells me. Code letter modulus. Oh, code letter is a modulus equals 26. I want to take the modulus there. Okay, so our text to encode is going to be, let's say, I would like to order a bowl of soup. And the phrase that we're going to use to encode it is going to be warm weather. So what happens here is it makes it very difficult to understand, because W is like, what is that, 20 or 21? So it takes I and it pushes it forward like 20 positions. So it goes all the way past Z and then wraps around the E. And then this space doesn't get displaced by the A. But then the W gets displaced by how many positions down the alphabet the R is. So it goes all the way around to the N. So using this to encode your messages makes it really difficult unless you actually know what the original message is.